Introducing Thales of Miletus, the dawn of Western philosophy. Thales of Miletus stands as a towering figure in intellectual history. Born around 624 BCE, Thales is revered as the father of Western philosophy. His contributions span philosophy, mathematics, astronomy, and engineering. Thales is credited with predicting a solar eclipse, showcasing his understanding of celestial phenomena. This was a testament to his belief in human reason and observation. Before Thales, natural phenomena were explained through mythology. Thales challenged this with his idea that the universe could be understood through reason and observation. He proposed that water was the fundamental substance of all matter, a significant departure from mythological explanations. This idea laid the groundwork for future scientific inquiry. Thales's revolutionary approach marked a turning point in human thought, inspiring subsequent generations of philosophers and scientists. His legacy lies in his bold pursuit of knowledge and belief in human reason. Thales's contributions laid the groundwork for the intellectual advancements that define our world today. The life and times of Miletus, a man of many pursuits. Thales hailed from Miletus, a vibrant trading center and intellectual hub. His travels to Egypt and other lands enriched his knowledge, making him a merchant, statesman, engineer, and philosopher. Thales's multidisciplinary approach and curiosity exemplify the interconnectedness of ancient knowledge. Thales's legacy reminds us that the pursuit of knowledge knows no bounds. Thales in Egypt, seeds of intellectual curiosity. Thales's travels to Egypt proved particularly influential in shaping his intellectual development. The journey itself was no small feat, considering the vast distances and the challenges of ancient travel. Yet Thales was driven by an insatiable curiosity and a desire to learn from the most advanced civilizations of his time. Egypt, with its rich history and profound knowledge, was a beacon for scholars and thinkers from all over the ancient world. Ancient Egypt was renowned for its advanced knowledge in mathematics, astronomy, and engineering, evidenced by the grandeur of the pyramids and their sophisticated construction. The pyramids, standing tall and majestic, were not just tombs but also a testament to the Egyptians' understanding of geometry and their ability to apply this knowledge in monumental ways. The alignment of the pyramids with celestial bodies further showcased their astronomical prowess. Thales's sojourn in Egypt exposed him to this wealth of knowledge, sparking his curiosity and laying the groundwork for his groundbreaking ideas. He spent countless hours in the libraries poring over ancient scrolls and engaging in discussions with Egyptian scholars. These interactions were crucial in broadening his understanding and challenging his preconceived notions. According to ancient accounts, Thales spent several years in Egypt studying with Egyptian priests and immersing himself in their teachings. The priests, who were the custodians of knowledge, shared with him their insights into the natural world, mathematics, and the cosmos. This period of intense study and reflection was instrumental in shaping Thales's intellectual trajectory. He is said to have learned geometry from the Egyptians, who used it extensively in land surveying and construction. The practical applications of geometry in building structures and dividing land fascinated Thales. He saw the potential of these mathematical principles to explain and predict natural phenomena, a realization that would later influence his own work. Thales was also likely influenced by Egyptian cosmology, which viewed the universe as an ordered system governed by natural laws. This perspective resonated with Thales, who began to see the world not as a series of random events, but as a coherent system that could be understood through observation and reason. The Egyptians' meticulous study of the stars and their movements provided Thales with a model for systematic inquiry. Thales's time in Egypt was instrumental in shaping his philosophical and scientific outlook. The exposure to Egyptian scientific instruments and their methods of observation and measurement left a lasting impression on him. He began to appreciate the importance of empirical evidence and the need for precise measurements in understanding the natural world. It provided him with a foundation in mathematics and astronomy, and more importantly exposed him to a different way of understanding the world. The Egyptian approach to knowledge, which combined practical application with theoretical insights, was a revelation for Thales. He realized that true understanding came from a synthesis of observation, experimentation, and logical reasoning. The Egyptian emphasis on observation and practical application of knowledge resonated deeply with Thales, and would later become hallmarks of his own approach to understanding the universe. He carried these lessons with him back to Greece, where he would go on to lay the foundations of Western philosophy and science. Thales' journey to Egypt was not just a physical voyage, but a transformative intellectual adventure that forever changed the course of his life and the history of thought. Water, the essence of existence, according to Thales. One of Thales' most significant philosophical contributions was his belief that water is the arch, the fundamental principle or element from which all things are derived. This concept represented a radical departure from the prevailing mythological explanations of the cosmos. Thales sought a more rational and observable explanation for the diversity of the natural world. He observed that water was essential for all forms of life. He saw it transform into different states, solid ice, liquid water, and gaseous vapor, yet remain fundamentally the same substance. This led him to conclude that water possessed a unique ability to change and take on different forms. Thales' choice of water as the arch may seem simplistic today, but it reflects a profound observation that beneath the apparent diversity of the natural world lies a fundamental unity. While his specific theory about water was later superseded, the underlying idea that the universe is ultimately composed of a single, fundamental substance paved the way for the development of atomic theory and our modern understanding of matter.